This right here is plain old soil I gathered from my garden. And the thing that blew my mind about electricity when I first started out was that you can use such soil as an electrical conductor. I mean, yes, here the light bulb acts a bit strange because of the size of the copper wires. But if we use bigger metal plates to penetrate more soil, you can see that the light bulb works perfectly fine with soil as an electrical conductor. This conductivity of soil, earth or ground or however you want to call it is one reason why it is so special and important for electricity and thus electronics. I mean, there are dozens of grounds around us. A normal AC appliance cable has a ground wire. My main distribution board has several big ground bus bars and is even directly connected through metal rods to literally Earth's ground. And let's not forget that pretty much every circuit I ever designed has tons of grounds in it. But do all of these grounds mean the same thing? And what is their purpose? Well, in this video I will tell you just that by doing some experiments you should definitely not do at home. Let's get started. This video is sponsored by JLC PCB, who combine the strength of large-scale flexible manufacturing with intelligent digital transformation, providing the most cost-effective one-stop electronic and mechanical manufacturing service platform. So click the link below and get their Black Friday coupons to save money on PCBs, PCB assembly, 3D printing, and CNC machining. And now 3D printing prices even start as low as 30 cents. Crazy! Now let's start off with the thing every one of us uses every day. And that is of course an AC power cable. That, like I already said, comes with a ground wire. In our case here in Germany, it is the green-yellow PE, aka protective earth wire. And the keyword protective already gives us a clue about its function. But before getting to that, let's imagine we got a normal household appliance, like my dirty old toaster here. If we hook it up to mains power and turn it on, then we got our brown L1 aka live wire and our blue N aka neutral wire, between which we have a voltage of 230 volts that powers our toaster. Now, as you would expect, the toaster is getting hot inside, because its resistive wire that comes with a resistance of around 53 ohm now gets penetrated by around 4.34 amps according to Ohm's law, or 4.4 amps when measured in real life. The point why I'm showcasing this here is to demonstrate that with just a live and neutral wire you can power your appliances perfectly fine. So why do we need an earth wire here, which connects to these metal parts of the plug and these springs on our outlets? Well, by using my multimeter we can pretty easily find out that ground is directly connected to the metal chassis of my toaster. And it is there, like teased before, for safety reasons. For example, let's imagine the live wire inside our appliance either came loose or the wire experienced some mechanical stress and thus lost part of its insulation. Now the live wire touches our metal enclosure, and I think everyone knows that metal usually conducts electricity pretty well. So if you touch the metal chassis now, then you directly touch 230 volts AC. And because you're more often than you think somehow connected to the earth, which is also a reference point for our house wiring, we gotta close circuits, and thus current can flow and things can get dangerous for you. To prevent this, the earth wire is not only directly connected to the metal housing, but also to our neutral wire. This connection is done inside or near the main distribution panel, which I can sadly not show you because mine is locked there. So as soon as live and earth touch each other, we got a big short circuit current flowing, which is actually a good thing. And to prove that, let's simply try it out with the toaster. And yes, we got big sparks and all my lights turned off. This cutout happened because the protective devices inside my distribution panel tripped, which are for one a normal circuit breaker and also an RCB. Now the circuit breaker tripped because of the big current flow, and the RCB tripped because the current flowing through live and neutral were no longer the same value, since this time current flowed through the ground wire. And before this test I expected only the RCB to trip, because it requires way less current to activate. But hey, both protections would have saved my life in combination with the earth wire. Meaning, summarized, its purpose in AC cables is that we do not get electrified. Nice. But did you notice that while explaining the circuit tripping parts, the actual earth, ground or soil never got mentioned? So why is it an earth wire? Well, the reason can be found when following the earth wiring inside my panel, which leads to a bus bar that connects to a thick metal rod that is pushed into the earth for sometimes up to 9 meters. Now, as we discovered earlier, the earth can be used to conduct electricity. In my case though, the resistance is still quite high with a voltage drop of around 55 volts, and of course changes when more or less moisture gets introduced, or when sand layers appear. But with such a long rod, you usually get a pretty low resistance. Meaning yes, there do exist electrical systems that use the earth itself as a conductor. For us though, that is not primarily the use case. For us, it is more about the problem with static electricity. In case you do not know what that is, then simply rub your feet on a carpet or rub your body on your couch, and then touch something big and metallic. You should have felt a sudden pain in your finger, which was actually a big discharge current. You see, through the rubbing you build up an excess amount of electrons on your body, which through the touching of the metal object quickly flow to it, to create an equilibrium of electrons. Now measuring this electrostatic voltage difference is not really easy to do. But with this charge generator here, you can easily see and hear that high electrostatic voltages can be a bit dangerous, not only for sensitive electronics, but also, for example, for someone working on your solar panels that gets shocked and then falls off your roof. My favorite example here is from Marco Reps, who actually measured and felt high voltages at his solar panels. Such voltage gets created in the extreme case by lighting, but also way more often simply through the atmosphere. And that is why we earth such metal parts, aka connect them to earth, to get rid of the static electricity, which I also did in my previous video about my own mini photovoltaic system. The reason is that earth mass does not only come with interesting electrical properties, but it is also truly humongous. That is why that when some excess electrons flow into it, its potential that we define as 0 volts does not really change. And since some electrons get sucked out at one point and some inserted at another point, we truly get a common ground reference potential here. And that is basically why we earth all metal parts everywhere around us. Now of course, the topic of earth goes even deeper than that for our electrical grids and power distribution. But for now you should not only understand that in our everyday life it basically protects us from getting shocked, but you should also understand why this electrician joke here is funny and not really funny at the same time. And that brings me to the last big question. Why do my circuit schematics come with lots of grounds? I mean, in very rare occasions they do actually mean to connect to earth, but most of the time they simply mean that all those points connect to one common potential, which is mostly the reference potential, aka 0 volts of our DC voltage. So yeah, this is not really earth, but since our earth is a big reference potential at 0 volts as well, this analogy probably spilled over to schematic designs. And to solidify this analogy, I would like to add that when doing two-layer PCB designs, you usually use the bottom layer as a big continuous ground layer, to which many components on the top connect to, which once again is super similar to the earthing concept we talked about before. And with that being said, you should now understand that earth or ground is awesome and why you hear it very often when it comes to electronics. If you enjoyed the show, then consider supporting it on Patreon. As always, don't forget to like, share, subscribe, and hit the notification bell. Stay creative, and I will see you next time.